This is section 3.2, problem number 7. Two parts to it. First part, consider population with data. Mean is 30, standard deviation is 3. Compute the coefficient of variation. Now I've written down here what the coefficient of variation is. First of all, it's a measurement that does not depend on any units of measure. There's no inches or anything like that. It's good for comparing measurements from different populations. Here's the formula for it. What do? You take the standard deviation, divide by the mean, and make it a percent, right? Just multiply it by 100%. Looks like we're going to have to use S and X bar being the 3 and the mu equals 30. So we'll use mu and sigma in place here. So we're going to use a 3 here, a 30 here, times 100%. So this is going to be, well, we could write 1/10, right? But how about this? 0.1 times 100%. So 0.1 times 100%, that gives us a coefficient of variation equal to 10%. Part B says, well, this is talking about Chebyshev's theorem. Now here's Chebyshev's theorem. It says if you have a set of data, 1 minus 1 over k squared percent of the data lies within k standard deviations of the mean. What it's telling us is this. We have a set of data here, and if this is the mean, all right, now what has to happen is that k has to be greater than 1. If we were to go out 2 standard deviations, say we go out here to here, here to here. All right, if we go out 2 standard deviations, like from here to here, what we have is at least, okay, at least, I forgot that wording in here. It's Chebyshev's theorem says at least 1 minus 1 over k squared percent of the data lies within k standard deviations. So if we go out 2 standard deviations, right, I'm here at the mean. If I go the mean, let me get this to right, the mean minus 2 standard deviations, this would be the mean plus 2 standard deviations. We would get at least 1 minus 1 over 2 standard deviations, 2 squared, 1 minus 1/4, 3/4, that's equal to 75%. So if we go for any set of data at all, if we find the mean and go out 2 standard deviations, how much data is in here? At least, all right, at least 75%. I'm going to write a few of these up here. If k is equal to 2, we just did that one. What you get is, all right, all of these are in terms of at least. Right? If you go out 2 standard deviations, you get at least 75% of all the data. If you go out 3 standard deviations, all right, then I'm going to do this down at the very bottom. It would be, all right, when k is equal to 3, you get 1 minus 1 over 3 squared, 1 minus 1/9, that's 8/9. That turns out to be 0.8888 and so on. That's about 0.89, so you get at least 89% of all the data. So up here at the top, if you go out 3 standard deviations, you get at least 89% of all the data. You can try this one here. If k is equal to 4, that's 1 minus 1/4 squared, 1 minus a 16th, 15/16. That turns out to be at least 93 point, I'll round it off, 93.8%. Now our problem says, compute an 88.9, that's actually this one right here, I rounded it off. Compute an 88.9 Chebyshev interval around the population mean. All right, so the mean is 30. Now we want to get a lower limit and an upper limit. So let me get some room here. Let's draw a picture of what's going to take place here. Here's all of our data, and here's the mean, which is 30. Now we want to create an interval around the mean that's 88.9% Chebyshev interval. Or 88.9%, that's k equals 3. All right, so we're going to go k equals 3. We're going to go 3 standard deviations in both directions. It says within, so within means below and above. So if we go 1, 2, 3 standard deviations, this would be 30 plus, you know what, I'm going to do it in general first. It's this. It's mu plus 3 standard deviations. Down here on the left, there's going to be 1, 2, 3. This is going to be the mean minus 3 standard deviations. Now let's actually put in the numbers. The mean is 30 minus 3 times. Standard deviation up here at the top is a 3. All right, so we're going to get 30 minus 9, so we'll get 21 as our lower limit. And the upper limit, okay, now I'm computing over here. The upper limit here is going to be 30 plus 3 of those standard deviations, which is a 3. 30 plus 9, that's going to be 39. All right, so here's our interval. We're going from 21 to 39, and that will capture at least 88.9% of all the data is in that interval. So to answer the question, the lower limit, let's put in a 21, and the upper limit, we'll put in a 39.